Hello guys, and welcome back to our Simplus tutorials videos. So last day we talked about vision. We talked about how you can feed the algorithm, feed your algorithms with input data from your camera, from the Simplus, what you're gonna be able to do, and we talked about. We didn't really talk about real challenges. We just wanted to give you a basic idea about what you can do and what can be achieved. And picking up where we left last day, today we're gonna finish our final section, the planning section, which is, in my opinion, it's a little bit easier than the two last sections. And so if you have come along with these two last videos, I'm sure you will have no problem understanding this one. This is actually a very easy one. We're just gonna call some functions. We're not gonna do something real crazy in the code. But there is some theory, there is some ideas that I want to talk about before we get to the code that may come up. They may be a little bit challenging, but there are fundamental ideas, fundamental strategies for any sort of any robotic competition, maybe. And I really want to talk about them because when I myself started working in robotics and AI, I found these algorithms, these techniques very fundamental and very useful. And they also give you a very, very good understanding on what a robot is actually supposed to do, especially in a competition like rescue simulation. So let's come here, and you may already be familiar with ROS system. I'm not going to really talk about it. There are just some articles on their website that I find very useful and find very intuitive. So the main thing we're going to talk about today is planning, how the robot is going to actually make some decisions, and then this is the main idea, all right? This is the theory part. This is not the coding part. We're going to get to the code in a few minutes. So here, this image is actually explaining a DWA, or dynamic window approach, right? This is an algorithm for moving the robot, okay? And once we want to move a robot, we generally tend to need two planners, right? Two planning algorithms. One of them is usually called a global planner. A global planner is sort of like a algorithm where it just shows the overall path to the destination. All right, so let's say you want to move from one city to another city. You need a global planner to tell you which roads you're going to need to take, which highways, which cities you need to cross, and just an overall view of your main route or your main path. Now, once you hit the road, there are times when you want to turn left, turn right, speed up, or maybe slow down a little bit, and that's the job of a local planner, right? Now, DWA, dynamic window approach, is it's a local planner, all right? So as you can see here, there are several branches, okay? And on each branch, we're going to see several points, black points. Now, this is our robot. These red areas are obstacles, okay? So what the DWA does is it generates many different trajectories with many different destinations, okay, for a single time step. So DWA says after one time step, the robot can end up at all these black points, okay? So each one of these black points represents the destination that the robot can reach in a single time frame by taking a specific trajectory. And obviously a trajectory is defined by setting the linear and angular speed. Now, once these trajectories have been generated and these destinations have been calculated, now the algorithm, based on several criteria, determines which one of these trajectories is the best one, is the most efficient one, is the most optimized one. Now, the way that we can optimize this trajectory is based, as I said, based on different criteria. Obviously, we don't want the robot to hit an obstacle, okay? So that's one criteria. if one of these, as you can see, for example, these points are too close to obstacles, all right? So they're gonna receive a negative score. These points, no, they're not close to the obstacle, so they're not gonna receive any penalty for getting close to obstacles. However, for example, this trajectory moves the robot further, all right? Further compared to this trajectory. So this trajectory may receive a higher point, a higher score. Actually, the points on this trajectory may receive a higher score compared to this one. And as I said, there are different criteria, but as you can see, these two are the most basic ones. How much the robot is going to get close to the final destination, its goal, and how close the robot is going to get to an obstacle. This is a DWA, okay? So keep this algorithm in mind, because once we get to the code, we're going to talk a little bit about it again. Right? Now, onto the global planner. So as you can see, for example, this is a global path, okay? This area is obstacle. It's considered non-traversable. Robot can move here. Robot can move on this area, okay? Now, let me... Alright,